In this video, we're going to start the next section, which is on systems of linear equations and determinants. But we got to get some terminology and stuff out of the way first, so that's what we'll focus on here. A linear equation is the first thing we need to know what that is. And linear equation is when each term contains one variable to the first power or a constant. We usually look for one variable to the first power. So if you look at these three examples, these are all linear equations. In the first one, we see 5 multiplied by x to the power of 1. T is to the power of 1. 6 is a constant, and it equals a constant. And similarly in the next two. All the variables are power of 1, and they're all in terms by themselves. The following ones are not linear equations. And the reason is, well, here we have x squared, so power of 2, not a linear equation. This term has two variables, x and y, so not a linear equation. And in the last one, we get this fraction, and the fraction itself is okay, but the problem is the variable is in the denominator. So really, if we brought that up, it would have y to the minus 1, which is not equal to 1. So this is also not a linear equation. We can have linear equations with one unknown, which would look like this, ax plus b equals 0, and an example would be something like 2x plus 1 equals 0. And you can solve that directly for x. We can move the piece over, find that 2x equals minus 1, so x equals minus 1 over 2. So one equation with one unknown or one variable we can solve. We can also have linear equation with two unknowns, or 3 or 4 or 5 for that matter, any number we want. But if we have two unknowns, x and y, here a, b, c are all constants, that would be something like 2x minus 4y equals 7. Now we can't quite solve that and get a numerical value for x or y unless we know x or y to start. And so that's kind of what we're getting at here, is if we know x, so for every x, we can get y, there's a y. Or vice versa, if we know y, then we can get x. Also, in discussing linear equations with two unknowns, we need to know that an xy pair, so written x comma y, can be a solution to the equation. So a pair xy is what gives us a solution, not an x or a y alone. And if we graph this, so this is typically how you see written y equals mx plus b, okay, where m is the slope and b is the y-intercept, and we'll see that shortly. But if we graph something of that form, we get a line, and every line is a solution because every point on the line satisfies the equation. If we take two equations with two unknowns, we get what's called a system of linear equations. And to get a solution for that, we need an xy that's a solution not just to one of them, but to both equations. So we have to put x and y in, and it needs to be true in both cases. In example 1, we have a linear equation, and we're telling you that 3, 1 is a solution. And what that means is if you put 3 in for x and 1 in for y, remember x, y, then the answer is 9. So if we check that, we get 2 times 3 plus 3 times 1, x and y substituted. And we're checking, does that equal 9? So we're asking ourselves, is that true? Well, this is 6 plus 3, so that's 9. And that does equal 9. So yeah, that's good. That is the solution. This one, you can quickly see that 2 times 5 is 10, plus 3 times 1 over 3, which is 1. So 10 plus 1 is 11. We're trying to see, does that equal 9 from up here? So 11 does not equal 9. So this is not a solution. And that's what we do to check solutions. For this one, we're asking you to actually find a solution. And to do that, if we have two variables, we need to tell you what one of them is. So we're telling you, here's our linear equation with two unknowns. If x is equal to 1, what is y? So what do? We plug 1 in for x, move all the pieces to find y is minus 1, and we get the solution. Finally, we have example 3 here where we're asked, is a equal negative 2, b equal 1 a solution to the system of equations? So remember, for this to be true, it needs to be a solution to both the first equation and the second equation. So we're going to check in the first one. We get negative 2 in for A plus 5 times 1 in for B. And we're asking ourselves, is that negative 7? Well, negative 2 plus 5, is that negative 7? And of course, that gives us 3, which is not negative 7. So it doesn't work in the first one. If it doesn't work in one of them, it's not a solution. So therefore, we use 3 dots to represent therefore, negative 2 comma 1 is not a solution. That's where we'll end this first lesson. Just giving you the idea of what a linear equation is and what a solution is. Try a little extra practice from your book on that. If you're comfortable with that, then move ahead to the next lesson where we'll start talking about exactly what we can do with the linear equation when we start graphing the line. As always, email me, comment on the videos, or come see me if you have any questions, and we'll see you in the next lesson.